Right. So, hello everyone again. My name is Dimitri. I want to welcome everyone to our tech talk today, GenAI and operations research in production. So today we're going to discuss the synergy between GenAI and the real-world experiences people face in both industry and academia. So we joined by two wonderful speakers, Dr. Levy and Anastasia, whom we will introduce shortly. So this event is organized by Inform's San Francisco Bay Area chapter. So I'm a Dimitri. I'm a board member of the chapter, and I'm an applied scientist at AWS. And I'm joined by my co-host, Vinod, who is also a board member and a data scientist at Stitch Fix. So we are very happy to have you all there. And since this is a tech talk, we are highly encourage your questions. So you will have two opportunities to engage. So first, after each presentation, there will be a dedicated Q&A session where you can post your questions in the Zoom chats, or you can unmute yourself. And the second, we're going to have closing discussion. We will conclude with a 25-minute open discussion and the Q&A close out. So yeah, this is our speakers for today. Yeah, that's I introduced already. And this is our agenda. So yeah. Do you have anything else you want to add?
No, I think, yeah, we have a solid agenda. Both our speakers are here. Looking forward to this.
Great. Great. Then let me introduce our first speaker. It's Dr. Levy. And yeah.
All right. Can you hear me? Yes. Yeah, today it's my pleasure to introduce Dr. David Simchi-Levi, a global leader in supply chain management, business analytics, and data-driven decision making. If you have attended a recent Informs event, whether national or the analytics conference, you most probably would have run into him or like heard him give a talk. Dr. Simchi-Levi is the William Barton Rogers Professor of Engineering Systems at MIT, where there he heads the MIT Data Science Lab, and he concurrently serves as a distinguished professor at Purdue University. He's also a member of the National Academy of Engineering and a recipient of the Informs Impact Prize. His PhD students have accepted faculty positions in leading academic institutes, including UC Berkeley, CMU, Columbia, and honestly, the list goes on. Beyond academia, he's founded multiple companies that shaped real-world supply chain optimization and analytics. In today's talk, he'll explore how manufacturing and supply chains are evolving from intuition-based decisions to fully data-driven systems, and how emerging technologies like LLMs are transforming the way organizations interact with these models. And in the pre-chat, like he even said that he said that he's even trying to introduce some new material for the first time to this group as well. So please join me in welcoming Dr. David Simchi-Levi.
Thank you. Welcome, everybody. Let me ask you to allow me to share. And do you see my screen?
It's coming up.
Yeah,
yes,
yeah, we can see it.
Perfect. So I'm going to talk to you, as Vinod said, about supply chain transformation with AI and large language model. I'm excited about this talk because the last part of the talk is completely new, just fresh out of the oven. And I would be very interested in comments and reflection on what I will describe. Let me hide the floating and bring a pointer. You can see my pointer, right? All right. So I'm going to start with just a few observations that if you are in supply chain, if you're in business, if you're in manufacturing, you are familiar with. And this include geopolitical instability and trade uncertainties, taking into account, of course, what has happened over the last 6-7 weeks. Significant shortage of labor, starting with the beginning of the pandemic, with people departing the labor market, as a result, putting pressure on executives to do the same or even more with fewer people. Increase in cost of material the last couple of weeks of energy and the cost of transportation. Lack of end-tier visibility, and by this I mean lack of visibility to upstream facilities and suppliers. I work, for example, with automotive industry, automotive manufacturing companies don't have visibility to tier 2, tier 3, or semiconductor chip manufacturer, wafer manufacturer, which are typically tier 6 or tier 7. So if something happens there, it will take quite some time for them to hear about the disruption. All of this require companies to focus on efficiency to cut costs, on resiliency to respond to a disruption, and on productivity to do more with fewer people. The problem is that these are conflicting objectives. If you, for example, focus on resiliency, it typically means more inventory, more redundancy, but these do not come free, and therefore it conflicts with our objective to reduce cost and improve efficiency. One way to address these conflicting challenges is by combining data, analytics, and automation, and that's what I'm going to focus on today. Of course, the space of analytics is huge. Let me just organize it in a very intuitive way and explain what I'm going to focus on. And for people at Inform, I don't need to explain, but it would be nice to understand what's new and what's evolving. So what I have on the X coordinate is complexity, how easy or difficult it is to do the analysis. And on the Y coordinate, I focus on value to the organization. The lowest level is descriptive, just use data to answer the question, what happened? Nothing is new here. Companies have done this for many, many years. A little bit more involved, but still something companies have done for many years is diagnostic. Don't only tell me what happened, but try to explain why did it happen. Again, nothing is new here. I'm going to focus on the top 3. Predictive, using AI and machine learning to understand consumer behavior or predict demand, predict supplier performance, supplier lead time, supplier quality. If I can predict well, I will use prescriptive optimization or simulation to optimize decisions. And if I gave this talk 2.5 years ago, 3 years ago, that's where the framework would have stopped. Over the last 2.5 years, we started adding generative to automate decision-making processes. And this is a little bit surprising because generative is based on large language models, technologies that was designed to generate text that has the look and feel of text generated by human. I'm going to show you here, and we have demos to illustrate how we can use the same technology to automate decision-making processes. So that's the framework. I'll focus on the top 3, predictive, prescriptive, and generative. And in terms of business, I have 3 objectives. The first one is to use this type of capabilities, especially predictive and prescriptive, to transform processes. Look at the complexity of supply chain and businesses, and see how I can transform and improve and maybe introduce new processes that will have an impact on bottom line. If I can do that, then my second objective will be to drive automation, to see if I can automate some of these processes. And if I can do that, then I will ask, can I enable autonomy? Now, automation and autonomy are not the same thing. By automation, I mean we, the human, tells the machine what the rules are, and the machine is trying to follow our policy. For example, we tell the machine if X happened, do Y, but if W happened, do something else, right? So all the rules and the policies are defined by human. Autonomy is different. In autonomy, we let the machine generate the policy and the rule, and as the environment is changing, the machine is trying to adjust and fit the policy to the new environment. And one of the questions that we'll ask is how capable the technology is in terms of achieving partial or full autonomy. And here I'm not talking about driverless cars, I'm talking about managing your entire business, managing the entire supply chain. So I will start with transforming processes, then add automation, and then focus on the last part, focus on autonomy. So the first part, which is all about driving transformation, started with work that I've done for a large fashion retailer in 2017, 2018, using AI machine learning, predictive and prescriptive, especially optimization, to transform the supply chain. I later on had an opportunity to collaborate on a similar transformation with a large CPG, consumer packaged good manufacturing company, from there to industrial manufacture, from there to high-tech companies. These are companies in different industries with different business requirements. But as we did the work, we realized that there are 4 key capabilities that cuts across industries and cuts across the companies that I collaborated with. The first one is replacing what industry call consensus forecast. What is consensus forecast? In consensus forecast, supply chain is a forecast, finance is a forecast, sales is a forecast. Each generates its own forecast, and then the different functional areas come together in a consensus meeting to agree on a compromise, not clear that this compromise correctly represents market demand. In unified view of demand, we transform this process by agreeing on the data and then let the machine generate a single forecast that is used by different functional areas at different level of granularity. Supply chain, SKU week level combination in the case of the CPG for the next 80 weeks. Finance is not interested in SKU level forecast or a week level forecast, so we use bottom up to aggregate all weeks within a month, all SKU within a business unit to generate a financial forecast, right? Same signal, different aggregation level. Once we do that, we replace one-size-fits-all supply chain strategy with a segmented strategy where we cluster product, market, and channels into segments, each of which has its own supply chain strategy, and then we build synergies across the different segments to benefit from economies of scale and reduce complexity. One way to illustrate this, if you think about your product, the supply chain strategy, even the manufacturing strategies that you will use for high volume, low volatility product is going to be different than the supply chain and manufacturing strategies that you will use for low volume, high volatility product. And then we bring together unified view of demand and segmentation into a closed loop planning process that continuously balance supply with demand. As effective as the plan is, there are deviations from the plan, supply disruption, changes in demand. In smart execution, think about this as control tower. Our objective is to identify those deviations, disruption, and changes quickly, and then respond to them effectively. So if you think about these 4 capabilities, the first 2 are purely AI and machine learning. The third one, closed loop S&OP, is mostly optimization, sometimes simulation, and control tower is a combination of AI and machine learning to detect deviation, disruption, and changes, and then optimization to respond effectively to the deviation and disruption. These are all built on a data platform that allow us to aggregate, visualize, normalize data. It relies on an effective network that takes into account and emphasizes the resiliency of the supply chain. And if anybody is interested, I wrote multiple papers on supply chain resiliency. And then typically it leads to an end-to-end, I call it here supply chain plan, but it's really end-to-end business plan. All of these are described, the focus on AI and machine learning are described in a paper I published about 2.5 years ago in Harvard Business Review. You notice nothing to do with generative AI, all is AI, machine learning, and predictive and prescriptive optimization and simulation. Over the last 2 years, we started adding a level of generative on top of this process, in the same processes, but we added a level of generative to automate decision-making. And this is described in a Harvard Business Review piece that I published a few months ago, in fact, last year. I'll talk a little bit about how we use generative AI to automate decision-making. But before I do that, let me give you an insight. What is the benefit of focusing on predictive and prescriptive initially, and then adding generative? And if you are in supply chain or manufacturing, you're familiar with many KPI that the company is focusing on. Typically, these are conflicting KPI. So here is an example. On the X coordinate, I'm focusing on responsiveness, from short response time to long response time. And on the Y coordinate, I'm focusing on efficiency, from low cost to high cost. And that the solid line here represents the trade-off curve between the two. And the intuition is very clear. When I emphasize short response time, then the cost is high. Why? Because to achieve short response time, I want to position inventory very close to market demand. I can respond very quickly, but cost of inventory and supply chain is very high. On the other hand, if I emphasize low cost, I want to centralize inventory, position inventory upstream, or even produce to order. This allows me to reduce cost, but response time is low. What we do with the capabilities that I described, we push the trade-off curve in a direction of improvement. Because if I can do that, then I can improve on multiple dimensions. For example, if A represents the current strategy before the improvement, then I can reduce cost and maintain the same response time by moving from A to C, or I can reduce response time while maintaining the same cost by moving from A to B. And there are lots of strategies between B and C where I do better than A. And in fact, supply chain segmentation allow me to position the different segment in different locations along the new trade-off curve. Now, this is an intuitive explanation of what I'm doing. A more specific one with data, ignoring for now GenAI, we improve forecast accuracy by, in all the implementations that we have done, between 10 to 30%. This allows us to increase service level, which implies better customer experience, reduce lost sale, which implies increase in revenue and significant cut in cost. That has nothing to do with GenAI. This is just predictive and prescriptive. When we add generative, we get the same benefit, but now because we automated processes, we get significant savings in planner times. I'll show you examples where we saw dramatic impact in a system that has been running now for 18 months in a company you know very well. So that's an intuitive explanation. Now let me explain in more detail how we use GenAI to automate processes. Remember, initially it was to transform processes. Now it's all about automation. So let's start with processes that company use before pre-GenAI. Pre-GenAI, I have a business unit, think about a planner, interacting with the data that the company has. Some of the data may be external, and the technologies that the company is using. The technology may be O9, Canaxis, E2Open, SAP, whatever the technology is. And of course, a lot of time, the planner is looking at the recommendation from the technology, and he or she do not understand. For example, they generate a forecast, and the forecast is not consistent with their intuition. So they don't understand why is it too high or too low. They generate a forecast, they send it to finance. Finance send a message, I don't understand. You just gave me a forecast for June, but last month you gave me a forecast for June, which is different than the forecast you're giving me now. Why is it? If I cannot explain it, nobody will use it. Or there is a recommendation from the technology on a fulfillment strategy. If the planner does not understand it, he or she will override it, or he or she will call the data scientists, data engineers, to try to explain what's going on, why the recommendation is what it is. It typically implies long planning cycle. Typically, planners do not trust the recommendation for the technology, so they manually change it. And if you compare the forecast that was used relative to the forecast generated, enormous difference between the two. And the decision process completely manual. What we did in multiple implementation is to replace data scientists and data engineers by LLM. LLM can translate. They can translate from English to Chinese and back from Chinese to English. We can therefore teach the technology, train the technology to translate from the language of the planner to the language of the technology that the company is using. For example, the planner is asking, I don't understand, why are we using supplier A to satisfy the demand for product B? LLM knows that we are using integer programming or optimization model. LLM will transfer this question into a constraint. Tell me what happened if I don't allow to generate flow from supplier A to demand B. It's the same technology running with additional requirement. The technology is generating a result that says, when you don't allow A to satisfy B, your cost is 2760. LLM knows that when we allow supplier A to satisfy the demand for product B, the cost is much lower. It responds to the planner, hey, if supplier A is not used to satisfy the demand for product B, the cost increased by 11%. What we found, and I'll show you in the next slide a few examples, that this lead to fast and data-driven decision-making. It explains and therefore provide insight to the planners. And in our implementation, we saw 20 to 40% increase in productivity. Let me review very quickly 4 case studies that illustrate the implementation and the impact. The first one is implementation at Microsoft Cloud Supply Chain. We all use cloud services. The infrastructure that support cloud services is massive. Microsoft has maybe hundreds of data centers. Each data center has thousands and thousands of servers. We use a technology, the way I described to you in the previous slide, for demand planning and for fulfillment decision. Microsoft reporting 20 to 30% improvement in planner time. The second is a large, very large European online fashion retailer. Our technology, the way I explained earlier, is used for demand forecasting, forecast demand for about 1.5 million styles in 23 different European countries on a weekly basis, use this forecast to optimize price and then automate the entire process, because nobody can manage pricing on a week-to-week basis for 1.5 million SKUs times 23 different countries in a manual way. We show dramatic using transformer, the engine under large language model, significant improvement in focus accuracy, dramatic improvement on bottom line, and a process that is completely automated. We have example on procurement in the automotive industry, and inventory example for a very large retailer. I will not spend time on this because I want to take you now through a little bit more insight. There is a paper that we recently posted that talk about how we use the framework I described in previous slides, integrating generative AI with optimization to develop insight, to provide explainability, for interactive planning, and then for responding in real time when there is a disruption. What I want to now spend a few minutes on is the last part. I talked about transforming processes. I talk about automation, and now there is a lot of excitement, especially among consulting companies, about autonomous supply chain, where AI makes all supply chain, for example, inventory, production, procurement decisions in an autonomous way. And my question was, how close are we for this development? We develop a test bed that you can play with on my website that allows you to design the specific configuration of your supply chain, select which agentic AI technology you want to use, and not only compare performance among different technologies, but also we compare performance relative to human decision maker. And we had about, I think, 100 plus human decision maker that we collected data from, and we compared with the technology. We published our initial results in a Harvard Business Review piece at the end of last year. So let me quickly give you some of the key insight. So what you see here is the average performance of human. Remember, I had about 100 plus people, so this is the average of human decision makers. I'm looking at total supply chain cost, and you can see initially we compare human decision makers to non-reasoning models. Think about non-reasoning model as the very first generation of large language models that were introduced in 2024, not a long time ago. And you can see they are not competitive with people making decisions. Clear cut. However, if you take the latest generation reasoning model, I'll tell you which one specifically, that were released last summer, so August of 2025, they already, vanilla reasoning model, beat human decision makers significantly. Staying with non-reasoning, if I add an orchestrator, what is an orchestrator? An orchestrator is an agent that makes no decision. In our test bed, we have agents that make retail decision, distribution decision, wholesale decision, and production decision. So this agent make decision about how much to produce, when to order, when to deliver. The orchestrator is an agent that only decide how much and when to share information. Does this make sense? Only decide how much and when to share. You can see non-reasoning with orchestrator, dramatic improvement, already beating human, comparable to a reasoning model. Now, staying within reasoning model and asking the questions that you have in mind, what if I add orchestrator? This is nicely described here. Again, here is human, remember, average around about 100 plus people. I'm focusing on two reasoning model, GPT-5 and Llama 4. You can see the observation I made earlier. Reasoning model beat human by about 30%. When I add an orchestrator, significant reduction. And when I added an orchestrator plus policy, these are guardrail, and I'll explain why we need guardrail in a second. 60% reduction in cost relative to human. Unbelievable impact, right? But forget about guardrail, forget about orchestrator, reasoning models, just vanilla make significant improvement. Now, so when you look at this, you tell yourself, wow, this is unbelievable. But there is a catch here. And the catch is how reliable these results are, how reliable autonomous supply chain. And the reason I'm emphasizing this, I reported to you average performance of the reasoning model, like I reported you average performance of human. So I ran the reasoning models maybe 30 times, and I report the average. But the question, if you are running your business, is not the average. The question is, what is the tail probability? Am I from time to time making big mistakes? Because if I am, nobody will use it. So that's the question I want to answer. What happened if in our test bed, each agent is managing the test bed 30 times? How much deviation we have in the performance? Does this make sense? And if and whether or not the agent performance is reliable, is consistent, or maybe the long tail is very risky. From time to time, the agent is ordering thousands of products. Nobody is going to let agent run their supply chain if they are not reliable. So to understand order instability across agent, I am showing you here this figure where you can see I have 4 agent, retailer, wholesaler, distributor, and factory. I'm running the model for 25 weeks, and you can see here the colored box. It represents all the decisions, for example, made in week number 25. The green is the distributor. All the decisions that represent the order quantities between 25% and 75%. So rank all the order from the lowest to the largest, and show in the box the 25 percentile all the way up to 75. You can see big range. And then you can see many outliers. I don't think there is any executive who will be willing to let agent manage the supply chain when you see all these outliers where the agent basically are ordering some large numbers that may kill your business. And so the summary here is very important. The variance in order is amplified. You can see in the first few weeks, when I run the system, the variance is very small. But as time goes by, the variance is increasing, and increasing for all agents. Does this make sense? It's increasing for the factory. It's increasing for the distributor. It's increasing for the wholesaler. The retailer, it's not increasing much because the retailer face customer demand. So they have certainty about what the demand is. And so this implication on the reliability of the agent is an important challenge. So the question is, how can I increase reliability? Does this make sense? Because nobody, given the performance I showed you, is going to use the technology that I described. One way that the computer science community is advocating is that, look, LLM are stochastic models, just sample, regenerate recommendation multiple times, and take either the average or majority voting. Majority voting, very simple, just take the one recommendation that appear multiple times. And the question is this going to solve the problem? Unfortunately, it does not. So here is a default when I did not use what the computer science community recommend. You can see the reliability is low. If I use 10 samples, it's remained the same unreliable outcome. And if I use 100 samples, same thing. Nothing is solved. So the question is, what can we do? And this tells us that you need to be a little bit more sophisticated and require training. And I just want to conclude this talk by telling you what we did. We took, I'll tell you which one, LLM agent, and in order to increase reliability and reduce the risk of large orders that destroy the supply chain, we basically trained the model and changed the parameters of the LLM. And the way we did it was we started not with the real demand. We don't know what the real demand is going to be. We generated synthetic demand. Let me repeat, we generate synthetic demand. We run the model, basically using simulation to measure the cost. We gave this cost information to the agent, and we use reinforcement learning to fine-tune the parameter of the LLM. And surprisingly, here are the default when the agents are unreliable, but with fine-tuning of the parameters. Look at this. We completely eliminated all the large orders. Basically, the performance is mostly deterministic. So let me just summarize what I described. Our experience from the testbed is that there is a big difference between different large language model, and selecting which model you are using makes a big impact. Guardrails are very important. Orchestrator makes a big impact. Fine-tuning, we use it in two different ways. First, fine-tuning performance with better prompt. It matters what is the prompt that you give the agent. And finally, and critically, fine-tuning LLM parameter with synthetic or real data if you have it. We did not have, so we use synthetic data, makes an enormous impact. The challenge here, and I will stop after this statement, not all large language models allow you to fine-tune parameters. Only a few of them. So you need to focus, if you want to fine-tune parameters, you need to focus on Llama or Owen from Alibaba that allow you to do that. Otherwise, you cannot achieve the performance that I just showed you. Vinod, let me pause here. I know I exceeded my time a little bit. Hopefully it provided some insight to everybody.
Yes, no worries. We had like a couple of comments come in, but I think like they were probably like responded or covered in the talk. Does anybody have a quick question before we go to the next speaker?
I have a quick question. Hopefully, the time allows. I wonder if Dr. Simchi-Levi, if you have thoughts that who in the market would be suitable, working on such a project, like having LM replacing data scientists in supply chains.
So that's great question. We now implementing not fully autonomous. Remember how I started, but partial autonomy in a few companies. I mentioned Microsoft Cloud Supply Chain. That is a system already running. It's clearly not fully autonomous. There is human in the loop. We are now, my team here at MIT is implementing at a very large pharmaceutical company. Not fully autonomous, like you are indicating, but partial automation. So what you see here is maybe the North Star, but what it tells you is we can increase productivity, reduce error, accelerate decision making with this type of technology significantly.
Sorry, I guess my question is more focused on will it be like vertical, like industry per industry, and you have a solution for each industry versus horizontal?
I see. It's another level of question. What we found is we need to do the training, the implementation, not only by industry, forget about by company. There are lots of buzzwords out there that, okay, these software companies are developing things that are generic and cut across companies and industry. This is so far not our experience. Does this make sense? I showed you in one supply chain how complicated it was to identify something that is reliable, and we needed to dig into the detail. So I don't think right now it's going to be a generic technology, even by industry. But, just caveat on this. The technology is evolving at a very fast speed. The clock speed is enormous. Remember, if I presented this talk in March of 2025, I would only talk about non-reasoning, and I would say the technology cannot be even competitive, right? And all of a sudden, we see reasoning and improvement. So the challenge, I think, related to your point, is given that the clock speed of the technology is so fast, and I'm a company interested in implementing some of this, how do I design it so that next month or 6 months from now, when the technology is improving, I'm not behind. I can take advantage of this. Does this make sense? But to me, this is a company by company rather than something generic. Of course, things can change very, very fast.
Cool. Thank you, Professor Simchi-Levi. I know you're going to stick around. So towards the end, we have like a combined Q&A session as well. So with that, let me hand it over to Dmitry to introduce our second speaker.
Absolutely. Thank you so much. So, yeah, thank you, Vinod, and thank you, Dr. Levy, to cover this very, very difficult topic and to give us more insights about current ideas in academia. So with that, let me introduce Anastasia. She is an experienced leader in products and a significant contributor to the New York startup ecosystem. So in today's talk, she's gonna to demystify the AI hype cycle, and she will share insights on how to prototype a product-ready AI product without a single line of engineer written code. So please welcome Anastasia with me.
Hi everyone. Thank you, Dmitry. Thank you everyone for having me. Let me share my screen. Okay. Can you see my screen?
Yes.
Okay, cool. Yeah, hi everyone. So my name is Anastasia. You can call me Nastia. I'm a product manager lead, and so a little bit about myself. That's okay. Sorry, how can I? Let me try how to I slide. Oh, okay, cool. Yeah. Also, Dmitry, thank you for introduction. Yeah, I am a product manager lead at RepRally. RepRally, it's a B2B wholesale marketplace backed by top accelerator Greylock. And before that, I was in Philips Auctioneer House and then at Yandex. And I've spent about 8 years of experience, 8 years building products specifically in AI, ML, product management. And I'm also a startup mentor at Techstar New York and the founder of Product Trends. It's a community for product managers with 6K members, where I'm helping product managers to develop their career and building great products. And today I want to talk about something that I think it's so exciting. Everyone right now building AI features, and it seems really easy right now. But because you can spin something up in the afternoon and actually really quickly show something to people, but to build something that's really can work and bring money, it's a really different game. So that's what I'm going to dig into. And first, I'd like to start how my working process has changed with AI. Just like 6 months ago, the whole team, engineering team, product team, designing team, they could spend like 4 6 weeks to build something valuable. As a product manager, I'm writing PRD. It could take 2 3 days. Designer should build some mockups, engineers building prototypes, and etc. And just to understand if your idea really works, you have to spend this time. Right now, with AI, this sprint started being really faster. Sometimes it could take just 3 days. You can just use Claude, Google Stitch, describe something, load real data into prompt, test, and iterate. Right now, it's really easy. And also, for the same scope, as I said 6 months ago, to build something, you need maybe like 7 people of the team. But today, for the same scope, you just need 3 people. And the same opinion also Logan Kilpatrick. He is a product manager at Google. Gemini, and he said that officially giving up with his PM title because right now all members in the team like technical stuff now because they are all builders. And I actually also agree with him because you, as a designer, as a product, as a data scientist, as an engineer, you can really try to figure out how the feature should look like, how the product should look like, and that's why you can just to build some prototype and show these people. And right now we have tools to build this. And that's why the design process is a little bit that, because the traditional cycle like research, diverge, converge, mock, handoff can't keep up. And because, yeah, as I said, like engineers can build prototypes in hours, PM really can ship features. And that's why the process has to change. And what designers can actually do right now, they can support execution because engineers build really fast, and designers can help them polish the prototype, give some feedback in real time. And also another side of work, it's set the vision. It's really important because in the world where everyone can build anything, someone needs to point the team in one direction. It could be a product manager or a product designer, but yeah, it's something that's changed right now because everyone can build prototypes. And here I really want to sharing my approach, what I am doing every day as a product manager, how to build products with AI that will actually work. And I wanted to start with the step one, with the so it's so foundation, it's the basic, it's forming a hypothesis. And here I want to ask you, what do you think, what the difference between an idea and a hypothesis? You can quickly use chat and just to write your thoughts. I will read something. Hypothesis is testable. Okay. Hypothesis is testable, idea is fun. Yeah, you are really right. Of course, hypothesis is something more than idea, and this is something that most of teams can miss. And for example, right now, when everyone can be a builder, they just, oh, I have an idea. I just go to Claude and just try to prototyping. But here I want to give an advice and just to say, hold on, please, because before doing anything, please stop and just to think of what you are doing and why. And here I just want to repeat before doing anything, what questions you need to ask. And they are first, yeah, good hypothesis is no flash. You get to the core of the problem. Secondly, if you can't mathematically capable of delivering results, you can't bring any valuable results. Before, if you want to earn money to drive revenue, before calculate, if you don't calculate this revenue in the Google Sheets, you can't bring this revenue in real time. The third point, a good hypothesis should be aligned with the product strategy, because the strategy could be different, and yeah, if it is as it is, and also it should fit with the existing product architecture, because if it doesn't fit, it could take a lot of resources, money, and yeah, it's good. You could meet a lot of constraints. And what else? Each good hypothesis should also include these answers. Why do you do that? What exactly do we want to change? Who are we building this for? And of course, metrics, how we will measure success. I'm using this template, and also if you are a builder, if you want to build some prototype, please, before building anything, just to put all these answers in this template. And you can see the difference, because really the difference matters. If you just want to improve, for example, if you show users personalized content during onboarding, based on their interest, retention will grow. This is not testable, and on the right side, you could see how the hypothesis, what hypothesis should include. Okay, and step 2. Design is not just a nice picture. The users hires your product to get a specific jobs done. And here I want to share my experience at RepRally. I'm responsible for marketplace for store owners, and their usual work is just to browse in marketplace and for their restock, to add something to the cart and place order. And here, RepRally already exists for 3 years. And when I started working on this product, I started thinking about what hypotheses we can test, what experiments we can launch, and of course, how to increase our key metrics. And for example, here, when we wanted to redesign the restock flow, making it easier to add to cart and place an order. We built a lot of features that could help us to improve experience and increase CR. We iterate a lot, build some bundles, challenges, rep support, and constantly shipping and testing new features for store owners. And everything looks nice, but we don't see such a huge, significant growth. We see that our users were interested in our product. They started being more actively, but we don't see any spikes in their experience. And we decided just to hold on and just to think what we do wrong, what we did wrong. And first question that we ask, not how to improve the product, but where do we have black boxes? Because this is that I described, like increasing metrics, improving user experience. It's like a general traditional product management work. But here we just during all our routine, we really forgot about new tools, new AI opportunities. And here and right now, we realized that some of black boxes that we would always think that we can't do with that anything. We were stopped and decided to think what we can do with some black boxes. And here we found that we don't need, of course, marketplace already works, what we can do else, what data we missed, what experience we missed, and how AI could help us. And here we found we have already reps. They would always, every day they visit stores, every day they talk with store owners, and what data they need, what problems they have. And here we found that our users, they really want to understand how to increase their margin, how to understand when to restock, how to understand which products are fast moving, which products they need to change because they just stay on their shelf and customers don't buy them. And here we found that we can use reps, capture shelf photos. AI could verify performance. We can document proofs of products. We can show what the retail price and etc. And overall, our goal started being not just to improve user experience in the current product, but also make offline retail as measurable and scalable as digital. Another example that this helped us not just to help our store owners, but also to help brands to understand what's happening with their products in offline, because all brands could understand their metrics through Amazon, Shopify if they sell it online, but in offline it's a black box. And here started just like changing our perspective, where we can drive our product, where we can use AI. We just make a pivot and just to make more value for both, not only for store owners, but also for brands. And this third step, it's before you integrate anything, before you show like iterate with your current product, prototype first. And it's okay. And it's okay to use external links. For example, For example, we have a problem. It's another case where where we want to help our stores, our reps, to help pitch their products. And before integrate into real product, because rep application is so difficult. This includes map to find routes, where to go, to plan went to deal to 30 stores per day, catalog of products, managing orders, deliveries, a lot of stuff. And to integrate the new stuff, it could be so difficult. And just to test our hypothesis, like how to improve pitch, how to increase deals, I'm just using Claude AI. I'm just using Claude, sorry, I'm just showing. Using real data, using our documents, create such a really simple tool how to pitch with real data, and just to give our users to test it. For example, here they could just choose store, they could just see the price, they could see sales tactics, and also they could practice how to pitch. And for example, for each store, for each brand, they could see the script, and just to try it, if they've never seen any product, they never sold anything, they would use this tool separately from product, and just to try. And let me come back to the presentation. And what's really cool, that when we launched this tool, we realized that it's not something that reps real needed. And after talking with them and shadowing them, like to see how they use our this external tool, we realized they don't have a lot of time to they don't have time to read a lot of information, guides, and etc. They just have 10 minutes. They have real conversation with store owner face to face, and they just need to get some quick answers if they have something, if store owner ask them in real time. And this external tool started being like our new AI assistant. It's completely different, but with the same idea that we need to help sellers to make a deal. And instead of building pitching tool for each brand product with some sales tactics, we are building AI chat, Ask Brittany, that could help sellers to understand what this store's needed, which deals this store has, which products we recommended, and really creating real-time recommendations per store for sellers to make more deals. And key insights of all this from all these cases. First of all, yes, you need to build trust among your customers, but through speed. I mean, like, ship early, iterate publicly, release the prototype, collect feedback, fix it fast. The wrong thing is shipping early and then going silent. You can't mock AI. You have to use real models, real data, real users to discover what actually works. And right now, designers' time, you need split and to make more collaborations between designers, data scientists, and engineers, and of course, managers. And just last slides, what's my personal AI system? This is tools that I'm using to build prototypes. It's Claude Code, VS Code, Cursor, it's alternative, Figma plus MCP plugin, and Cloud Cowork. Claude Cowork. And that's it. Thank you. This is my LinkedIn. I'm happy to chat, just to connect. And if you have any questions, I'm happy to answer them.
Thank you so much. Thank you. Yeah, I see there is a question in the chat. So do you prioritize automated feedback loops for such solutions, or what is your main priority for them? Like, how do you work with it?
Do you prioritize automated feedback loops? Yes, we prioritized because we appreciate iterations and iterate a lot. And we iterate a lot based on feedback. And in the reality, our team has like different teams, and for example, if we have such some goal, we like set the goal for like next 3 weeks. For example, we want to increase amount of deals, for example, per sale rep, and based on this goal we iterate a lot and also collect feedback. And when we see that we see the results, we can like do something else and do another priority. But in the like some sprint of the goal, we prioritized loop of feedback.
This is awesome. Thank you so much. That was my question. I was also wondering, like sometimes in the industry, a lot of companies are now using LLM as a judge. And I was wondering if we could pivot that question more into the space if you're using LLM as your feedback loop itself.
You mean that, for example, based on the feedback, we train our models, yeah?
Yeah, exactly. So you could incorporate LLM feedback inside of your model training process.
Yeah, inside of our model process, we are using recommendations, and of course, for example, we are using similarity between different stores. There are different patterns. We are using a lot of data that we are catching from Open API, and based on real behavior of users, how they add to cart, how they how they retain, and based on these signals, we would always train our models to be to show more relevant products.
Got it. Thank you so much. It's always interesting to learn. As a data scientist myself, it's interesting to learn product perspective as well. Thank you.
Yeah, thank you.
Thank you so much. So
All right. Now we come to the common Q&A part. So for this part, like we wanted to first open the floor to see if there were any generic any questions for either speakers. We heard like two very different but like very interconnected perspectives, right? So like one is more on like the intersection of like OR and like more like a technical side, like how to automate these things, whereas Anastasia was talking about like more like on the floor, right? So like how do you like work on the edge, and like both these are like interesting applications of AI. So did anyone have a question, any question to bring up?
I have a question for Dr. Simchi-Levi. And it might be too technical, so maybe you have a paper. So you mentioned at some point that adding a layer of GenAI on top of the optimization, the recommendation would help the user understand the recommendation from the optimization engine by doing some kind of sensitivity analysis, right? You put in a constraint, but this would mean that the LLM would understand the question, understand what constraint to add, and put it into the model, and then run the model, get the answer, send it back. Do you have any paper or?
Yep.
Yeah, okay.
Andrea, let me give the short answer, and then if you send me an email, I can send you the paper.
Oh, perfect.
So you are describing it correctly, right? The planner has a question. The LLM need to translate it into a mathematical model. It's not clear how the LLM knows what to do,
Right.
and
Right.
whether this is correctly fitting the mathematical models that already exist, right?
Yep.
So your question is very, very important. So the way we did it in the initial implementation is as follows. Just think about the process. We first interviewed the planners. We said, hey, give us all the questions that you have asked the data scientists and the data engineers over the last 3 to 4 years. And in fact, that was not difficult to achieve because they have an engineering log that we could explore. Then we took all the question, we manipulated each question because the way you ask a question, the way I ask a question, not necessarily the same. It's the same question, but we ask it in different ways. So we had hundreds and hundreds of different questions. And then we went to the planner, to the data scientists and data engineers. Here is a question. How did you answer this question? Now I have pairs of question and answers. These are the pairs that I'm training the technology. Now you may ask, okay, what about the new questions that you have not? If it fits within the convex hole of all the questions we ask, that's all good. But sometimes it's a new question, we have never seen it before. We basically tell the planners, these kind of questions, the technology has not been trained on. We tell the technology when this kind of question is asked, say, I am not qualified to answer. And then in the next training, we add this level of question and we retrain the model. The details are, of course, important. So if you send an email, the papers that I mentioned, I meant a paper that title was 4I framework. This is where we describe the process.
I got it. Thank you. Now, a little bit of a controversial question. Just curious because I am that old and I know the expert systems kind of booming era. So I wonder, there is a flavor of gathering all kind of the information in order to build this knowledge for the LLMs to be able to explain in a flavor that kind of reminds me of the expert systems. The difference is that here you don't have a deterministic if-then, but rather a random. So you add a layer of uncertainty on top of everything else, right? My question is, how scalable are these systems? Because that was the problem with the expert systems, right? They were not scalable.
So I don't have a deterministic answer to your question. I can just report all the implementations that we have done where we saw that scalability has not been so far an issue. Training was very important. I showed you also when you try to move to autonomous, reliability is an issue. But it was not an issue related to scale. It was an issue related to the hallucination and the random nature of the response by the technology.
Yeah, that makes sense. Thank you.
Thanks.
I have a question.
Yes, Peter.
So with regards to, you're talking about training with new data or data that's coming up, are you starting to, or maybe in the next stage, have plans to integrate existing knowledge bases like RAG systems into how the LLM does its work, or maybe even include an MCP that another inferencing engine uses the LLM that is trained as a specific LLM? Because even now RAG systems are very complicated. You have 5, 6 databases just for ingestion, and maybe you have different graph databases just for recall. Where do those play a role in your future plans?
So that's a great, it's not a question, it's really a comment. The way I think about this is not what we have done, just to be very specific. This is probably the next level of training that we will use to see how much we can use existing technologies to automate the process. We have done something, Peter, something similar. And let me be a little bit over technical. So think about the following process. You're an OR guy, you wrote optimization model, say a mixed integer program or an LP. You send it to Gorobi or you send it to Cplex and say, well, there is a problem, infeasible, and you are trying to debug. So we develop a process that allow us to automate the debugging of your model. Does this make sense what I described? So here we use other data. So it's not exactly what I describe about complete autonomous decision-making, but we use what you describe in debugging optimization model. This is a step forward. Like I said, this is moving so fast that I'm hoping that the next way we train models is based on available tools like you described. And Peter, if you're interested in how we did the solver in the loop, right? Solver LLM in the loop, there is another paper that I'm happy to share. Just send an email and you will get it.
Okay, thank you.
Anyone else?
I guess
Yes.
general question. You both talked about, how fast everything is moving. How do you think about trying to implement something when you know that like a month later there's going to be another agent that's going to dominate everything? How do you stay ahead of the curve somehow?
Maybe I'll let I've talked. Anastasia, do you want to take this? I'm happy to answer, but let me.
Curious for both of you, actually. But yeah. So
I'll tell you how I think about the problems that you describe. The challenge is the clock speed of the technology, as you are emphasizing, right? Changing so fast. You're developing now with current agent, and tomorrow it's something different. That's why modular product architecture is so important. So that when you build a modular design, tomorrow, there is a new agent with different capabilities. We may plug out the old agent and plug in the new agent. This is product design strategies that have been used for many years. You want to apply it also for systems of this type.
Yeah, I just want to add that approaches don't change. We just use another tools to implement, and right now you just use these tools to make everything faster. Or if it's really, really difficult decision or solution that you want to make, maybe it's better to stop and just to rethink and just to maybe think about how to set up the task.
So on a related note, like I have a question on the accountability side. So it's also like I'm combining, Dimitri, one of your question and my question, and both of you can answer. So we are kind of relying more and more on like AI to kind of make higher and higher level decisions, right? So in an automated manner. And there's also underlying complexity, right? So David, in your part, like you mentioned about currently like the business analysts and the OR scientists are in the intermediate layer. Now in the new world, it's like business can directly ask questions to AI and it'll translate things, right? So there are things like business rules and constraints that needs to go into that translation correctly, which currently we rely on humans, and we know humans with OR PhDs can hopefully do things right, but now we're giving it to an LLM, right? And similarly in Anastasia, in your part, right? So when we were providing strategies, like, AI is effectively helping you make that decision. So if decisions go well, great, no problem. But if it goes wrong, how does accountability work? Like, who is responsible, and how can companies think about managing that accountability and responsibility? So Anastasia, you can start, and then David, you can share your thoughts after.
Okay, yeah. It's fair if your decision goes wrong. Would always like humans are responsible for this, and we don't use AI just to use AI. You would always need to prove what are you doing, what you want to drive, and why you chose this decision. And even, for example, in the product mindset, if you did something and this was a fail, it's another result. It's not so bad. It's sometimes you just use this learning, do something better and greater. Yeah, it's like the same process like a traditional process, just you need to think how to prove that you use AI, not just for AI.
Makes sense. David?
Yeah, I agree with this observation. I'll just highlight the comment that was made by Anastasia, that you learn from situation where you fail. Remember, I showed you the autonomous supply chain that on average, it performed very well. But as soon as we started looking at individual decisions, we realized, hey, the variance is very high. And when you go and implement, nobody is going to let such a technology run when on average it's doing well, but from time to time it makes crazy decisions. That's where we learn how to fine tune the parameter of LLMs. That's where we learn how to select carefully which LLM to use. And I mentioned that not all LLM created equally. First, reasoning and non-reasoning. If you go to reasoning, some of them, like Llama and QN, allow you to fine-tune parameter. Others do not. So careful selection of the technology and human in the loop, also verifying that it's not about average, that it's on a day-to-day excellent performance is important as part of the process.
Cool. Thank you. I see we are kind of almost coming towards time. Like, is there any other question anyone wanted to ask while we have our speakers?
I actually have a very kind of high level and general question. How do you see the informs organization moving towards with AI development?
That's a great one.
You're asking me?
Yeah, I'll be very interested in your thought on this.
So I'll give you just my quick thinking about your question. I think for Inform, there is an enormous opportunity. And let me be diving into detail. It's an opportunity in two directions. One is how can we use OR to improve LLM? Does this make sense? That a little bit sounds fiction, but it's absolutely true, because LLM rely on scheduling all the tokens that are sent. Memory capacity is limited. OR technology, queuing models, allow you to optimize how do you manage the token and the prompt. So this is one direction, OR for LLM. I talked here about the other direction, LLM for OR. But at a high level, I think the opportunity is to combine OR, AI machine learning, and LLM to improve end-to-end business decision. But your question also implies that we need to rethink how we educate, both in engineering, in social science, and in business schools. And I will stop by making an observation. The large consulting companies who used to hire hundreds and thousands of MBAs from business schools are reducing the number and the type of people they are hiring from business schools, because they realize all these MBAs who can do PowerPoint and Excel spreadsheet, this is done much better, more accurate, much faster by the technology. So they are trying to look for people who can complement the technology to implement. So this is not just a problem for Inform. This is a problem for Inform, higher education, and industry. And in my view, we need a partnership between the three to move the baton to the next level. So you gave me a good question that has many implications beyond Inform. Thank you.
Very cool. All right. I think like we are coming to the end of our time. I want to take just a minute to give a huge, huge thank you to both our speakers. And thank you to each and every one of you for attending and asking these questions and participating on behalf of our Informs SF Bay Area chapter. This is what we do, right? We bring together great people, we bring together great audience, and we have these interesting discussions. And we would love to hear your feedback. Dimitri is flashing showing the QR code. I also once again put the link to the survey in the chat. Please take a moment to fill us in. This is our chapter, right? So this is our organization. What you want to hear, what you want to learn is what we want to organize and present. So please send us the information. And once again, thank you very much, David and Anastasia for this wonderful talk. And thank you, Dimitri, for being a wonderful co-host as well.
Thank you, guys.
With that, we will just keep in touch. Send us your feedback in the survey.
Yeah,
Bye.
thank you so much. Thank you.
Thank you.
Yep. Thank you all. Thank you.
Thank you.